Alright, this video is going to be looking at comparing two proportions. And when we are comparing two proportions, we need to have, to look at our notation. Again, we have two populations. So we have our population proportion that goes with population 1, and our population proportion that goes with population 2. That means we also have two sample sizes and two sample proportions. So just like with the means, the notation becomes really important in this video or in this test, and it's important to be able to keep your parameters and statistics straight. Alright, we're going to look at the two proportion Z test. Okay, this is when we have two populations and we're going to compare the proportions between the two of them. Okay, so just like with the two proportion t-test, we have two populations and two parameters. So we need to identify them in the same way. It becomes really important to identify your proportion 1 and your proportion 2. Okay, these are your population proportions, and you have to specifically make sure you state what the population and parameter are. In terms of your hypotheses, your null hypothesis is a statement of no effect or no difference. So our null hypotheses should be written as proportion 1 equals proportion 2. Remember that it can also be written as P1 minus P2 equals 0. As far as our null goes, we have several options. We could have proportion 1 is greater than, less than, or does not equal proportion 2. And those can be written in the same way as proportion 1 minus proportion 2 is greater than, less than, or does not equal 0. As far as our assumptions go, we have our same three. We have SRS, normality, and independence. As an SRS, make sure you check to verify each sample is an SRS. In terms of normality, we're going to introduce a new normality check. If you recall from a 1 proportion z-test, we were checking to make sure that n times p naught was greater than or equal to 10. However, in this case, we don't have a p naught. Remember, this is our null value, and we're just comparing to make sure that the two population proportions are the same. So we don't have this p naught value. So we need to create a new value, and that is known as p hat c, which is our combined sample proportion. Okay, and that is basically a combination of both population samples. So p hat c is equal to the number of successes in both samples, so basically x1 plus x2 divided by the number of individuals in both samples, which is n1 plus n2. So we're combining everything, or both our p hats, both our sample values. And once I have this, I'm going to check to make sure that n1 times p hat c is greater than or equal to 10, and n1 times 1 minus p hat c is greater than or equal to 10. And same with n2 times p hat c is greater than or equal to 10. And n2 times 1 minus p hat c is greater than or equal to 10. Okay, so we have to check that both populations are greater than or equal to 10 when they're multiplied by p hat c and 1 minus p hat c. And then our independence is the same. We have our population is equal to 10 times our sample size. Calculations. So the name of the test is a 2 proportion z-test. Okay, it uses the significance level in the same way. Our test statistic, z, is equal to p hat 1 minus p hat 2 minus our population values all over the square root of p hat c times 1 minus p hat c over n1 plus p hat c 1 minus p hat c all over n2. And then we use our p-value in the same way. We always have, and we make our decision based on our p-value. Remember that you need to link your alpha level and your p-value. If our p-value is less than our alpha, we're going to reject. And lastly, our interpretation. Our interpretation again is written as the same way. We have our first sentence was our alpha level and our p-value linked together, and then we have our decision whether we reject or fail to reject the null hypothesis. And then our second sentence is in context, and on your calculator this is the 2 proportion z test.